When we think about pressure, it's important to distinguish between atmospheric pressure and gauge pressure. Let's imagine a tank of water, and the water has a certain amount of height. Let's say 2 meters of water is in this tank. We learned the pressure equation for a fluid. Pressure is rho gh. So we don't need to know how wide the water is, just the height of the water to measure the pressure. Now we imagine taking a gauge, which is a device for measuring pressure, and we attach it somewhere at the bottom of the tank. So you see a little dial there. So this gauge will measure the pressure at the bottom of the tank. So what's the pressure that's there? Well, we can just use the formula. So we plug the numbers in. Remember that the density of water is 1,000, so what do we get? So this gauge will read 20,000 pascals or 20 kilopascals. So that's the pressure the gauge reads. That is to say, that's the gauge pressure. Now, this is actually sort of not correct because we need to consider the pressure due to the atmosphere as well. This formula we call absolute pressure, and we add a term at the beginning, P naught. And P naught is the pressure that comes from the atmosphere, 100,000 pascals. So if we think about this tank of water, there is all this air above the water also pressing down. So all that air is pressing down on the water. So the pressure down here, absolutely, totally, is going to be a combination of the pressure of the water weight and the air weight down there. So what's the absolute pressure? So we have P naught plus rho gh, and we plug some numbers in. The absolute pressure is going to be 120,000 pascals. The best way to improve your grades is to do practice tests. On my site are free fluid practice tests. Click the link below to get a free practice test. Our team will even mark it and give you feedback on how you're doing. So the gauge pressure, what the gauge read there, that was just 20,000 pascals. But the absolute pressure is 120,000 pascals. So what's going on here? Why does the gauge here not read the absolute pressure? Basically, scientists and engineers are smart, and a pressure gauge is set in such a way that when the pressure on it is just the atmospheric pressure, it's going to be set at 0. So let's imagine a pressure gauge, something like this, and the arm goes to 0 when it's at atmosphere. Basically, what's happening is inside the pressure gauge is some air at air pressure. So inside the gauge is a pressure of 100,000 pascals, and on the outside is a pressure of 100,000 pascals. So at this point, there's no difference between them, and so the thing measures 0. Now, if we start adding more pressure, like pressure from that tank of water, that will then move this one up here. So the gauge pressure really is measuring any additional pressure beyond atmospheric pressure. And absolute pressure includes the pressure from the atmosphere plus the pressure from, say, that tank of water. Let's think again about the air pressure that's sitting on you. We said there's an atmosphere of pressure, 100,000 pascals of air pressure sitting on you pretty much all the time. When you heard this, I wonder if you thought, why don't I feel air pressure? That's kind of weird that there's air pressure on me all the time, but I don't feel it. Well, what's happening is something similar to what I said about the gauge. So here's a diagram of you, and outside you is, I'm sorry, I'm not very good at drawing. Outside you is 1 atmosphere of pressure, 100,000 pascals of pressure. But the thing is that inside you is also air and air pressure. Inside your eardrums is air, and in your lungs, and actually all your organs have evolved in the situation where there's air pressure on the outside. So your body maintains an equilibrium of pressure on the inside that equals what's there on the outside. We'll learn more about this later, but when there's a pressure differential, that's when fluids are going to move. We say nature abhors a vacuum, and the idea is that when there's an area of high pressure to low pressure, fluids will be drawn towards the area of low pressure. But here, the pressure between our bodies and the air outside is basically in balance. The only thing that's not quite true about this is we're always breathing, and our lungs are basically changing the pressure inside our bodies a little bit to allow air to come in and come out when we breathe. So actually, you could think about your lungs as a pressure differential creating device that is inside your body. You may have never thought about this idea of pressure being inside your body before. If you have, and if you've thought about the idea, I'd love you to write down a comment below. What are the thoughts that you've had about that before?